This question is testing about something very fundamental, our understanding of the most basic principles, right, and equation in the topic of radioactivity. Number one equation, right, is A equals to lambda n. So what this equation is really telling us is that the activity, which is the rate of change of the number of radioactive nuclei, okay, which is the minus dn dt. Why is there a minus sign? Because, right, the rate of change of radioactive nuclei, right, is a decrease, okay, whereas activity is just a number telling you number of particles given out, right? So one is a decrease, the other one is a positive number, that's why there's a negative sign. So this is telling us that the rate of decline of the population, right, is proportional to the population itself, okay. That's why there's a subsequent first order mathematics that arise, okay, as a result of this relationship. And the other one, right, is the relationship between half-life and the decay constant. So lambda equals to ln 2 over t half, okay, or you can write it the other way, t half equals to ln 2 over lambda. So with these two, right, we can look at the choices here. So for option A, right, the one with a shorter half-life will have a higher activity. Is that true? Well, shorter half-life will mean you have a larger lambda. However, right, activity is equals to lambda n. Just having larger lambda, right, or doesn't mean, right, the activity will be larger, because, right, the n is a question mark. Okay, the two sample may have different number of radioactive nuclei at the beginning, so you can't tell that whether larger lambda will mean absolutely activity is larger. Option B, right, activity of a radioactive isotope at any point in time is proportional to half-life. We can see, right, that this is definitely not true, because, right, the activity at any time, okay, equals to lambda n, okay, and is equals to ln 2 over t half, okay, times of n. So there's no relationship, there's no proportional relationship between these two. Yeah, so therefore this is false as well. Then option C, right, activity of a radioactive isotope at any time is proportional to the number of nuclei present at that time. So this is the only true statement. So this is telling you, this is trying to say that A proportional n, this is true. Okay. Option D, activity of a radioactive isotope at any time is proportional to the decay constant. Okay, this option, right, is very tricky. People may tend to choose this because, right, they will say that A equals to lambda n. So could we say that hence, right, A proportional to lambda, which is what this thing is trying to say? We couldn't, because, right, whenever we say something proportional to another thing, you're saying, right, one variable proportional to another variable. You never say that variables are proportional to constant, in which case, right, the lambda is actually a constant. Okay, so you wouldn't say that the variable is proportional to constant. So this relationship, right, is not true. Okay, whereas, right, A and n both are variables. Yeah, so this is a common misconception, right, that I hear from time to time.